Hey, how you doing today? Yeah, that's right, algebraic transformations. That's where we're at. We're into the last lesson. And so we've been talking about horizontal things, horizontal transformations. And so the last one left is horizontal reflection. It doesn't take very long. It's the simplest, it's the quickest, it's the thing that's easiest to learn. It is horizontal transformations, but it's reflection. It's the reflections down here that we're going to be looking at. And how do you reflect? Well, vertically we learn to reflect by multiplying by a negative value. That's exactly right. That's how we do it with horizontal thing. But where does it have to happen? If it's a horizontal thing, where is it? It's inside a grouping symbol. You're absolutely right. The algebra part, it has to be inside that grouping symbol. And so if we end up with, if we work with the same papa of the parabola that we've been so used to at this point, if I wanted to reflect that horizontal, now wait a minute, if I reflect that, let's look at the picture just a second, and if I take papa, look, I've got something on the left, I've got something on the right of that horizontal line, that y-axis. That's right, the reflections occur not over the up and down, but left and right. And so the line of reflection is that horizontal, that vertical axis we know affectionately as the y-axis more times than not. But it's that vertical axis that we need to reflect left and right to. But look again at the parabola, the picture. If I reflect the right thing over to the left and the left thing over to the right, it's not going to appear to have any change whatsoever. So what I want to do is choose another parent to work with, and let's make it be a cubic, because the left side of the graph, now we have something over here. Now this is on the right side of the axis, of that vertical axis. It's shift over here to the left, it would look different, and that on the left side would reflect over there to the right in that fourth quadrant, and it would look different. So again, how do we do that? We multiplied by a negative value, but that negative, to have a horizontal effect, has to happen where? Inside what? That's right. And so if I'm going to do inside horizontal things, I've got to do it to the x coordinate inside, but I got to stay in that family. So again, here's what the algebra looks like. Papa is x is y1, so that's y to the, or x to the third. And then I'm going to negatively multiply to the x, but inside that parenthesis, and keeping it in the family of cube. So let's see what happens here if I can find the graph key. There it is. It's reflected over. It folded, reflected over that vertical line to where the right things on the right side went to the left. The things on the left went to the right. That's right. So you see now a spider being incurred. Same kind of picture that we saw when we folded it down or had a vertical reflection, but we're doing it left and right. So there's examples, and so it looks very. It can, again, the artwork sometimes is difficult to tell what you did. But now you're equipped. Hey, you're ready to go. You've got all that you need, all the skills of transforming algebra into the picture that you want to create the algebraic artwork that you desire. Now you can put together all kinds of different parent graphs. As a matter of fact, I will give you some. I might as well just do it right here. Again, we can use parent graph of x squared. We can use x to the third power, and that's a cubic function. You can use x to the fourth powers. Again, those get different when you mess with them a little bit. You can use, here's one of my favorites, x to the -1. And I will show them to you so that you can see them as we keep building. X to the -1 power. That's hyperbolic and very nice. I like the way that artwork does. Let's see. There's the absolute value. Of course, you can do absolute values of x's, and that's a parent graph. Again, the absolute value of it. Again, we're using the graphing calculator. We have different ways of typing it in. And then we can go square roots, but you have to do square roots or cube roots. You have to do both vertical and horizontal if you want it to graph up and down. So there's another the two functions that I typed in, the 5 and 6, are two functions that go together to make one picture of a parabola. Actually, that one will open to the right, and graphing that, and I'll show you what that looks like real quick because I've got some time. But you can mix these parent graphs. You can mix and match. So there's the two functions. That's the square root functions, and you'll see that they open to the right. It looks like a parabola now that's opening to the right, which we hadn't seen before. Okay, hadn't seen those parabolas open to the right. We don't see them opening up and down. There you go, algebraic transformations. You got it all in a nutshell. These 6 videos will be able to help you. Now, we do need to learn how to use the graphing calculator because your algebraic artwork is going to be created there. We will work on that in class, and then you will be able to ask questions and how to do those things and capture those keystrokes so that you can use the graphing calculators. Create your artwork. We're going to print it out. You're going to title it. It's going to be kind of like an ink blot, and you'll see that artwork and you'll give it a title. And then you can color it and have some fun with it and create some artwork that was actually developed and designed by algebra functions. And this is lessons of algebraic transformations. Hey, young Jedi, you are now worthy of going forward. And as Master Yoda gives you the instructions, artwork wonderful, create you will. Later.